So our goal, once again, is to get it into a form of ax to the n. And when we have it here, we don't have that. But knowing our knowledge of algebraic expressions, if I have this all divided by t, I can put each one of my numerators over the denominator. Because if you think back to if I had 2/3 plus 4/3 plus 7/3, if I have 2/3 plus 4/3 plus 7/3, to add those fractions, that is 2 plus 4 plus 7 all over a value of 3. I just add the tops and keep the bottom the same. Well, what we're doing is we're taking this and moving it back to here. Okay? So now what we have is 1 over square root of t. Well, square root of t in an exponential form is t to the what power? 1/2. So we have 1 over t to the 1/2 plus t over t to the 1/2 plus t squared over t to the 1/2. Well, if I have a like basis, what do I have to do with my exponents when I'm dividing? Subtract them. So what this turns into is this turns into just t to the negative 1/2. This would be t to the 1th minus 1/2 plus t to the 2th minus 1/2, or 1/2. So we subtract our exponents. So we have t to the negative 1. This gives me plus t to the 1/2 plus t to 2 minus 1/2 will give me 3/2. And once again, our goal is to take the antiderivative of this with respect to t. So we have now accomplished what we wanted to accomplish. My coefficients to all these are a value of 1. So you have negative 1, and don't try to do too many things at one time here. Okay? Try to keep it simple, because this is hard enough as it is, because it's all new to us, to try to shorten and cut out steps. As you go through this and you get some practice and experience with it, that will become easier to be able to maybe shorten some steps. But keep it simple right now. So we have negative 1/2 plus 1, so I have a 1/2. So we have 1 divided by 1/2. 1/2 plus 1 gives me t to the 3/2. So we have 1 divided by 3/2 plus 3/2 plus 1 gives me 5/2. So we have 1 divided by 5/2 plus c. When I have 1 divided by a fraction, what do I have to do with my fraction? 1 divided by 1/2 is 1 times 2 over 1. This flips our fraction. So we are left with 2 here. This gives me square root of t. This flips this one over to give me 2/3. One plus 1/2, so this would give me t to the 1 times t to the 1 times t to the 1/2. So we have t square root of t. Plus this will flip over to give me 2/5. This gives me 2.5. So we have t squared square root of t plus c. I could factor if I wanted to a square root of t out, but we don't need to. We're good with that. Morning, boss.
Morning, Mr. Gregory.
How are you doing today?
Greg, how you doing? What was your dinner last night?
It was good. Have you ever ate over at the Leaf over in Worcester?
The old...
Not the green leaf.
Oh, the leaf.
See,
That's a little pricey.
I was confused because I'm thinking, okay, we're gonna have to beat up the grandmas and grandpas, but then I thought,
But you go about 7 o'clock.
if we go at 6 o'clock, they're all gone.
Yes.
They've already hit their dinner time specials.
Yes, I agree.
They're already gone. They're going home, and they're out of the way already.
You know, I make fun, but this is what the Watkins family does. Because they're like, let's get the Longhorn around 2:30 in the afternoon. We'll get some steak in us, head home. By 4:30, we're in our PJs.
And we don't have to wait in line for an hour for a table.
Exactly. So
Oh,
we're on the couch watching TV.
I eat dinner at like 8 o'clock.
Happy as could be. Yeah, we're in bed by then.
yeah. Us old folks, we've learned that rule. We've learned that too.
Well, that was very nice.
Yes. So it was good. There's a downtown. They've really done a nice job in downtown
We've
Worcester.
done it in the last like 5 or 6 years. Where have you been? You not been downtown lately?
No. But they have some nice restaurants down there now. They've made the apartment buildings like where the old Freelander. You probably don't even remember.
I do
Freelanders.
remember the Freelander.
Up
And then you
above
also had the clothing stores back to back.
Yeah, but above that is all apartments. But
Yes.
they've now made those really nice apartments where
Been
you
down
have.
there, Rich. Yes, with the nice restaurant.
Yes.
You know, City Steaks Warehouse. Now it's pretty expensive, but they have a bar menu.
So
It's pretty good.
Yes, see,
The bar, like
we don't
Good
fit.
job there.
We don't fit the expensive city steak.
Oh, no,
menu.
we go in,
don't-
we sit in the
don't make it
patio,
there.
and we just put the
We
bar
get the
menu.
we get the appetizers.
That's called the bar menu.
We're not that high pricey. We're old. We're trying to save our pennies, you know. We're going into
What's
retirement.
the one on the corner? The Chinese place. It's not bad.
Basil's?
Basil.
Yeah, Basil's.
Basil's good. We haven't had that.
The sushi there is so good.
Yes,
I feel like sushi.
I get sushi there.
So yeah.
Broken Rocks is good.
Yeah, but the Leaf is right down.
Rocks is-
Yeah. So right by Basil. It's across the street from Basil.
So I mean, it was good.
Have you been to, I think it's called like Operation Fandom or something? Sorry, this is just my favorite store there. It has like a ton of cool stuff, like sci-fi people.
Oh, really?
Yeah, I just wouldn't think like we'd have that in Worcester.
Yeah, Worcester's stepped up the game.
Yeah.
You know what they've done is they have competed against and made the playing field even with the North End,
Mhm.
with the the Texas Roadhouse or whatever's out there,
Well, that's not on the North End.
or whatever
Longhorn.
Longhorn.
There is a difference.
Yeah,
Texas. Have you had Texas Roadhouse?
Rolls?
yeah.
It's like top 3 for the Watkins family.
all three of the you
We
got
went to that
Roadhouse, you
Saturday.
got all those.
No, don't say they're all the same. They're not.
But in my mind, they are. To me, they are.
Okay, Longhorn,
Because
Texas
you don't
Roadhouse.
go
What's
to
the
eat
third
much.
one?
There's a third one.
Outback.
Outback Steakhouse.
You know, Texas Roadhouse, or Longhorn and Outback, I can compare those two.
Yeah.
And think they're about the same.
See, and we don't go out.
Except Texas Roadhouse, they are increasing their prices by 2.5%.
Really?
The rolls are worth it.
They're free.
The rolls are worth it.
The rolls
With
are
butter,
so
with the honey butter.
good.
You'll sit down, you'll have
It's like
3 by the
honey
time you
cinnamon.
even realize what happened.
What place used to have the peanuts?
The Texas Roadhouse.
But they don't do them anymore.
Yeah, they still do them, but they do them in individual bags. They don't put them on a tin.
Yeah, see, to me, that was the.
So you can still do it. I think you have to ask for them now.
That was the pull into that, and no, they're not there anymore. Throw them on the floor. That was awesome. But
I don't think you were really supposed to throw them on the floor. You were supposed to throw them back in the tin.
But too many peanut allergies anymore, I
This
guess.
guy.
I make my own rules. I'm old.
I didn't even come in here. I don't even know.
See, old people, they start varying those rules a little bit to make them fit to them.
Yes.
But like nobody like even like bats an eye when like
When Mr. Gregor comes in,
no,
throws
not
peanuts
Mr.
all over
Okay,
the
no,
place.
I'm not calling Mr. Gregory old. But like whenever like old people do something like weird, everyone's just like, oh, they're old.
They're old, don't worry about it. They'll be okay. See, I can get away with that a little bit now. Not all the time, but I can still get I call it the OMS, the old man syndrome, that I experience.
When you go on your tangents and the soapboxes.
Yes, I just have my old man syndrome moments that.
We've all been there, Sid. We've all
We're
been
the
there.
ones that get it the most, I think.
What's that?
My trig class got a little taste of it this morning. My trig class.
About what?
Some of our
He's gonna go through the
algebraic
list.
some of our algebraic skills were somewhat lacking. Not trigonometric skills. The skills they should have learned back in Algebra 1 and Algebra 2. They were lacking a little bit. And
You got a little bit?
we actually, the thing that irritated me,
Look how quick you are though with that tech right there. Did you see that?
He's out of all the teachers, he's the best with the board.
the sine or cosine of 45.
He kind of just uses it as a whiteboard.
Sine or cosine of 45.
All the buttons down. He knows how to recalibrate it.
Oh.
Sine or cosine of 45 is 1 over square root of 2.
Okay.
But I say, we've been through enough mathematics that you should look at that and say, I could quickly rationalize that and come up with a rationalization of that. Where 1 over square root of 2 would rationalize to what?
Square root of 2 over
Square root of 2 over 2.
Yeah. Thanks for taking my thunder.
Square root of 2 over 2. So rather than writing down 1 over square root of 2, yes, you should be able to write that down. But you've been through enough of these. We've done sine cosine of 45, and we've done all this.
That's not algebraic though, is it? That's the rules of
Radicals, which is all algebraic rules. Okay, that's what
not
they're
radicals, but like just fraction.
Yeah, but that's what they should learn in algebra, and I should be
They
able.
probably did.
I should,
Oh.
but I don't.
Yeah.
But
Yeah, I used to read too.
but this is what if you didn't quite remember it, that's fine. We can rekindle that, and we did that throughout the entire semester so far. We've rekindled that idea of doing that. So it should be something that's somewhat familiar to you. Well, we go through a problem, and I asked one of my young lads, what's the sine of 45? And they said 1 over square root of 2. And I said, okay, rationalize real quick, come on.
That triggered the old man syndrome over here. TOS.
Crickets started.
That just fired you up on a Friday morning.
Oh,
didn't it?
yes, it did. So, okay, it went from 1 to, okay,
You called on somebody else.
I went to somebody else.
Oh no.
They didn't know
No,
it.
you didn't, Mr.
Oh, boy.
You called on somebody else again.
And here's the third one. Oh, boy. And off I went.
Okay.
Off I went. It was a good morning. Got the blood pressure up a little bit. Got the blood pumping a little bit.
I see
I was
that.
good to go.
Especially it's a little chilly outside. So. Did I at least enough to get
Still playing baseball, though.
Stay a little longer.
We're still playing baseball today.
Oh. Who?
Highland.
At Highland. Today.
Yeah. And our JVs are out here. And I walk down our field, and we should be able to play out here, I would think.
Softball tomorrow, Sid?
Softball tomorrow, and I went down to the softball field, and there's no water.
I don't even
You're home,
We're
double,
playing or for home away, I just go.
doubleheader home, we moved it to noon, so the, New York City people can get an extra hour of sleep tonight, just in case.
Even the old man is considered sometimes, Sid.
Yes.
I try to help out.
You do more than try. We'll see it.
Of
good
course.
talk.
You were throwing darts, huh?
Yeah, I was throwing darts. Let's see, where were we? You take any more in the front? We were able to make it through 11,
Yes.
where we have 3 square x of 1/2, 2 x of 1/3. And then we have to take the antiderivative of that, but we have 2 x of 1/2 and x of 1/3 for the second one, the cube root of x.
You just do 2x to 3.
So we have 1/3. So when we take our antiderivative with respect to x, we add our 1. So we have 3, or we have 3 halves as our new exponent. So we take our 3 and divide by 3 halves. Then we have 2. Our new exponent here would be 4/3. And we divide by the 4/3. So you may, to me, I always have to take it off the side. 3 times 2 over 3, which gives me 2. And then 2 times 3 over 4, which would give us 3 halves. This gives me 1 1/2. This gives me 1 1/3. So I will get 2 out of this. X, square root of x here. Oopsie. This will give me 3 halves. Then we got x times the cube root of x plus c.
Would we still get it right if we just left it in like the fraction form?
No, you need to simplify it. You need to simplify the radicals down. I'm not going to ask you to rationalize any denominators, but I will ask you to simplify your radicals down. Once again, forces us back to algebraic skills. This is what we were just talking about. On the back side, I'm not going to give you any second derivatives right now. I'll give you a problem like number 31. 31, f of x, f prime of x equals 1 plus 3 square root of x. F at 4 is 25. So let's look at 31. F prime of x equals 1 plus 3. Now, what I tend to do as I'm recopying the problem onto my paper, I would simplify, I would put your radical into an exponential form. Okay, so I have square root of x, put it in square x to the 1/2 power. And then we're given f at 4 is 25. You can think of this as a differential equation. We can think of this as dy over dx, and this takes it back just into 1 plus 3x to 1/2 power. We can multiply by dx. Dx So we're left with y dy is equal to 1 plus 3x to the 1/2 dx. Then to get rid of our differential, we can take the antiderivative. Or you can think up here, here's my derivative. How do I get rid of my derivative? I can take the antiderivative dx of both sides. So you can think of that. Once again, either way is the correct way of thinking about it. When I take the derivative of my differential, the differential goes away and just gives me back to y. Over here now I need to take my antiderivative, so go ahead and take your antiderivative on the right-hand side. Once again, the antiderivative of a constant, you just tag along an x. And as you get used to this, once again, you switch yourself out of the derivative mode. Derivative mode, took the derivative of the constant, I get 0. Take the antiderivative, I throw in the x. So we have 1x here plus add 1. Add 1, so we have 3 divided by, we have 3/2 divided by 3/2, which is, once again, 3 times 2 over 3. We get a value of 2 here. So we have y is equal to x plus 2x square root of x plus c. Once again, we don't know what the constant is unless we are given an initial condition. And we are given an initial condition. When x is equal to 4, y is equal to 25. So in my equation here, we have 25 as our y is equal to 4 plus 2 times 4 square root of 4 plus c. Now we can solve for c. 25 is equal to 4 plus 2 times 4 is 8. That's square root of 4, which is 2, so we have 16 plus c. 25 equals 20 plus c. C is equal to the value of 5. So what this equation turns into is y is equal to x plus 2 square root of 2x square root of x plus 5.
So they're looking for the equation as the answer, or like the
Yes.
answer?
You solve for the constant, but they want you to find what f is. They want you to take this. Once you find c, just plug it back in up here and rewrite. All right. Once again, all we're going to be doing Tuesday. We'll see about Wednesday where we're at. We're just going to go over and start practicing the antiderivatives and things that we've been working with here. So, solutions are posted for you. I think I got a set of solutions up here.